The Z-20J represents the culmination of a long-standing requirement within the People's Liberation Army Navy for a modern, indigenous, medium-lift shipborne helicopter capable of operating in the demanding and unforgiving maritime environment. Its development is intrinsically linked to the expansion and modernization of China's naval surface fleet, particularly the introduction of large platforms like the Type 075 amphibious assault ship and the Type 055 destroyer, which possess extensive aviation facilities that were previously underutilized by older, less capable, or more limited helicopter models. The helicopter's design philosophy centers on achieving a high degree of multi-role versatility, operational reliability, and seamless integration with the fleet's combat and logistics network, thereby serving as a force multiplier that extends the sensor reach and tactical flexibility of the vessels from which it operates. The airframe design of the Z-20J is a product of extensive research into materials science and aerodynamics, optimized for the dual challenges of performance and survivability at sea. The primary structure makes significant use of advanced composite materials, including carbon fiber reinforced polymer and glass fiber reinforced polymer, which are strategically employed in the fuselage skin, tail boom, and rotor blades. This material selection is critical for achieving a favorable strength-to-weight ratio, which directly translates into increased payload capacity and operational range. Furthermore, composite materials offer superior resistance to fatigue compared to traditional aluminum alloys, a vital characteristic for an airframe subjected to the constant vibrations of rotor operation and the dynamic stresses of shipboard landings. The design also incorporates a comprehensive corrosion protection strategy that goes beyond simple coatings. This involves the use of specific aluminum alloys, such as the 5000 and 7000 series, which are naturally more resistant to saltwater corrosion, and titanium components for highly stressed fittings and areas exposed to engine exhaust. The entire airframe is designed with sealed joints, drainage channels, and corrosion-inhibiting compounds applied to internal structures to prevent the accumulation of moisture and salt, which would otherwise lead to progressive structural degradation. The rotor system is a defining feature of the Z-20J's design and its shipboard compatibility. The 5-blade main rotor configuration offers distinct advantages over 4-blade systems. It allows for a larger disc area for a given rotor diameter, generating more lift efficiently, which is crucial when operating at high gross weights or in hot and high conditions. The 5-blade design also distributes lift across a greater number of blades, reducing the load on each individual blade and enabling a lower rotational speed for the same lift output. This results in significantly lower vibration levels and a reduced acoustic signature, both of which contribute to enhanced crew endurance during long-duration missions and a lower probability of detection. The rotor blades and the tail boom incorporate a sophisticated folding mechanism. This is not a simple manual process but likely a powered or hydraulically assisted system that allows the aircrew to fold the blades and swing the tail boom parallel to the fuselage in a matter of minutes. This transformation is essential for moving the helicopter from the flight deck into the confined space of the ship's hangar, where multiple aircraft must be stored, maintained, and prepared for subsequent missions. The ability to compactly store the helicopter is a direct determinant of a ship's aviation capacity. The propulsion system relies on two WZ-10 turboshaft engines, which are the product of indigenous Chinese aerospace engineering. These engines are estimated to each produce between 1,600 and 2,000 shaft horsepower. They are equipped with full authority digital engine control systems, which continuously monitor and manage engine parameters such as fuel flow, turbine speed, and temperature to ensure optimal performance across the entire flight envelope, from hover to high-speed dash. This digital control provides smoother engine response, improves fuel efficiency, and enhances reliability. The engine inlets are likely fitted with inertial particle separators or other filtration systems that use centrifugal force to eject sand, dust, and, most critically, salt spray from the incoming air before it enters the engine core, preventing erosion and corrosion of the delicate compressor blades and turbine components. The main gearbox, which transmits the combined power of both engines to the main and tail rotors, is designed with a torque rating that provides a substantial power margin, ensuring that the helicopter can maintain flight and execute a safe landing on a single engine, a fundamental safety requirement for overwater operations. The avionics and sensor suite of the Z-20J form an integrated network that provides the crew with enhanced situational awareness and mission management capabilities. The flight control system is a digital fly-by-wire system, meaning the pilot's control inputs are processed by flight control computers which then command the hydraulic or electromechanical actuators on the rotors and control surfaces. This system provides automatic stability augmentation, making the helicopter easier to fly, especially during the critical phase of landing on a pitching and rolling flight deck at night or in poor weather. It can also incorporate flight envelope protection, preventing the pilot from inadvertently commanding maneuvers that would overstress the airframe or induce a vortex ring state. The sensor package is comprehensive. A multimode maritime radar, housed in a radome typically located under the nose, is capable of performing surface search to detect and track ships, weather mapping to navigate around storms, and potentially employing inverse synthetic aperture radar modes to generate classification quality images of surface contacts. The electro-optical infrared sensor turret, also mounted under the nose, contains a suite of passive sensors, a high-resolution daylight camera, a thermal imager for night vision into see-through obscurance like smoke or light fog, and a laser rangefinder or designator for precisely determining target coordinates or guiding laser homing munitions. The cockpit is a glass cockpit, where traditional analog dials and gauges are replaced by several large, multi-function liquid crystal displays. These screens can be configured by the pilots to show a combination of flight instrumentation, navigation data, digital moving maps, engine and system status, and live video feeds from the sensor turret. Communications are facilitated by a suite of secure UHF, VHF, HF radios and a satellite communications terminal, allowing for secure, long-range communication with the host ship, other aircraft, and command centers ashore. In its operational employment, the Z-20J is a true multi-role platform. Its primary function is as an assault transport helicopter. The cabin is designed to accommodate 12 to 15 fully equipped naval infantry personnel in crashworthy seats that are configured for rapid ingress and egress. The cabin can be quickly reconfigured for a variety of other roles. For medical evacuation, it can accommodate multiple litter patients suspended in stacks along the cabin walls, along with space for medical personnel to provide in-flight care. For cargo transport, the internal volume can be used for palletized supplies or equipment, and the cabin is typically equipped with a cargo hook and a hydraulic winch for loading and unloading. For vertical replenishment, a heavy-duty external cargo hook is used to transport underslung loads, which can include containers, light vehicles, or artillery pieces between ships or from shore to ship. In an armed capacity, the Z-20J's capabilities are expanded for fire support and escort duties. The aircraft features two stub wings, which are structural pylons attached to the fuselage, each with hardpoints for carrying ordnance. These can be fitted with pods for unguided 70 mm or 57 mm rockets, which are effective for area saturation and suppression of enemy positions. More significantly, the hardpoints can carry launchers for precision-guided air-to-surface missiles. These are typically laser-guided missiles designed to engage and destroy armored vehicles, fortified bunkers, and small naval craft with a high probability of hit. For self-defense during troop insertion and extraction in hostile environments, the cabin doors are equipped with pintle mounts for general-purpose machine guns or heavier 12.7 mm machine guns, operated by crew chiefs or dedicated door gunners to provide suppressive fire. The operational integration of the Z-20J into the fleet is ongoing and represents a significant enhancement of the plan's capabilities. It has become the standard utility helicopter aboard the Type 075 amphibious assault ship, where it is a central component of the ship's air wing, working in concert with larger transport helicopters to execute complex vertical assault operations. Its deployment on destroyers and frigates, such as the Type 055 and Type 052D, provides these vessels with a highly capable asset for tasks beyond pure anti-submarine warfare, including surface surveillance, search and rescue over vast ocean areas, and vertical replenishment to extend operational endurance. While a specialized variant, the Z-20F, exists for the dedicated anti-submarine and anti-surface warfare role, featuring a dipping sonar, sonobuoy launchers, and a magnetic anomaly detector, the Z-20J's foundational multi-role design ensures it will serve as the backbone of the Navy's shipborne utility and transport aviation for decades. Its ongoing production and future evolution will likely see incremental improvements in engine power, the integration of more sophisticated sensor fusion algorithms to reduce crew workload, the adoption of more advanced composite materials, and the capability to employ next-generation networked weapons and systems, ensuring its relevance in the evolving landscape of naval warfare.